98% of you have man-made chemicals called PFAS in your blood. PFAS, or per- and polyfluoroalkyl substances, are a group of over 14,000 synthetic chemicals that are known to cause various cancers and birth defects. PFAS can be found in everyday items such as food packaging, water-resistant fabrics, and personal care products. And in areas near PFAS manufacturing, contaminated drinking water is a significant PFAS source. Just south of Fayetteville, North Carolina, is a facility that has been manufacturing PFAS since 1980, and they've contaminated thousands of drinking water wells. Counties that are impacted are shown in red on the map. In response, the North Carolina Department of Environmental Quality implemented what's called a consent order. And the consent order essentially requires the company to fix the problem they've caused and provide clean drinking water to these impacted residents. They have a few options, none of which are a silver bullet. The first option is to connect residents to municipal water. This isn't really feasible because the costs have to be less than $75,000, and this is a very rural area. The second option is to treat water from contaminated wells. The problem is that we don't know how long PFAS will remain in drinking water. The third option is to drill deeper bedrock wells, and this is where my research comes in. So PFAS tends to be more concentrated near the land surface. So the thought is that maybe deeper wells have cleaner water. Deeper bedrock wells have been used in the area for decades, but water quality has never really been evaluated. So could the bedrock aquifer be a good alternate drinking water source for these residents? To evaluate water quality, I went and collected water samples from some of these bedrock wells and collected data from local health departments on water quality. With the exception of elevated salinity in some of the wells, water quality was generally good. And most importantly, all PFAS were below applicable drinking water health advisories. Sounds like the perfect solution. There's a few problems. Long-term aquifer sustainability is unknown. Water levels are not being monitored. And the company is not required to pay for deeper replacement wells for these residents, and a new bedrock well can cost over $30,000. And this is further complicated because this area has greater rates of poverty compared to North Carolina as a whole. Needless to say, adapting to PFAS contamination is not simple, but my research shows that we don't always have to take the high road and connect residents to municipal water. We can take the low road below the contamination and think about deeper wells. Thank you.